So you got an application sample go web in the namespace Kubernetes training. It has its cluster IP, and here are its endpoints. That's all it does. So it provides you with a stable network identity as IP address and also implicitly as a DNS address, and then it points to some backend. That's all it does. There's no direct definition of a pod here. Now think, where in this example do we describe our pods? You can also open your browser, go to your to the replica set, and just look where are the pod details.
It's in the RS Hello World YAML.
Exactly.
But I let myself be fooled by its name.
Yeah, I can agree on that. Same for me.
Yeah, so fair point. So the answer is the pod definition that also contains the reference to the container, which references to, in particular, to container image, and the container image is the entity that refers to the actual code. Is that clear?
Yes.
Perfect. And all right. So the replica set contains a template to define the pods of the replica set. This is where the container image is referenced, and this is where actually the reference to your application code is. So if we look into the replica set here, you can see that there is a template. That's the pod template, and the specification of the template contains the definition of the containers. In this case, there's only one container called Simple Go Web C for container, and it refers to the container image Simple Go Web version 1. So I'll modify it and give it the version blue. Alright, so I changed my local resource file. Now what do I have to do in order to for this change to take effect?
It needs to be reapplied.
Exactly. Let's give it a try. kubectl apply. All right. So here we have 4 running pods. And you can see that the pod is still running as Simple Go Web 1.0.0. This is not the effect we wanted to achieve. Exactly right. So they're running. Doesn't seem that they plan anything else but to be running.
I have a short question at this point.
Yes.
So they are currently running, right?
Yeah. Yes.
When you apply a new YAML file,
Yeah.
updated Docker image, for example, then the existing ones aren't affected, right? So they at some point need to be restarted, for example, or yeah.
No, let's maybe kill one of the pods.
So when somehow, for example, the pod goes down and restarts itself, is then the container used that was originally described in the YAML part? Or is the new
Let's
one?
try it out. I'm already deleting one, so I'm throwing away the 78B4P. We'll take a second. We can look into. So one is terminating, and there are already 4 again. So there's a new one. G and G T M. This one is new. And now it's version blue. So if we do that often enough, we may get a blue at some point. So 1 in a 4 chance. So my question to you, is this behavior desired? Is that what we expected?
Yeah, so
Huh?
Well, I would have expected it in the process of applying a changed file. The pods would be cleaned up and recreated.
Exactly. That would be the behavior I would have expected too. Now, we've seen that the replica set ensures that the container definition, that the replica set definition, well, let's say, let me try to rephrase it. So you create a replica set, and the replica set has a specification. And the replica set controller reads the specification. It compares with the current cluster state. It sees there should be 4 containers running and creates them. And now you change the replica set specification. And obviously, it didn't recognize that the pod configuration changes. Which, to be honest, I didn't do this experiment when I created the tutorial. So I was surprised too. Because I expected it to make a deep equal to see whether the structures are the same and then replace it. But that's obviously not the purpose of the replica set. So let's look into the deployment, because obviously that's the territory of a deployment. So it seems that the replica set's main job is to provide an abstraction from the single pod to have a set of pods, and that the idea is that this set is homogeneous, that the pods are all the same, and that if you want to change the replica set in certain regards, so for example you can change the number of the pods, but if you want to change let's say the version of the pods, the software is running in there, then you have to forcefully delete the pods so that they are recreated, so that the controller will go back and read the specification and then change it. So it appears that the stateful set controller does not feel responsible for observing the container image field to then trigger a change. Well, that's what I would conclude from this observation.
So there's basically no restart or I don't know option whatsoever. Not restart.
Yes.
Refresh or something, so that the key controller automatically applies it onto all the currently existing and running pods. So you have to manually do it.
Let me check it. Yeah, right. So let's just keep on and proceed with the deployments. I think by observing the behavior as it is, we'll already get a feeling on what's actually happening. So we've seen that the replica set did not respond to changing the image, container image of the replica set. It did not replace the pods. So that's the observation. Okay, deployments. So obviously we want to have more control over what happens with the pods during a deployment. So the question is, what are the changes within your application? So let's consider two different application changes. So in this case, the blue-green, or even the transition from the tag 1.0.0 to blue, as well as the transition from blue to green, they're trivial, because it's nothing but a changed piece of text in the application source code. So it basically doesn't matter whether you have two versions of the same application running. You could, for example, see in our little test that that is no problem to have multiple versions of the same application running at the same time. So this is undesired behavior in some other cases where, for example, your application has two different database schemas. So let's say you have a version blue, and the version blue has a table called companies, and it only has two columns, ID and name. And then you introduce a third column, which would be description. So company now has a description. And your application code also makes use of this additional column. Now, in this case, the version, the green version of the application can only be run after executing a database migration, so that the newer version and the older version can work on a newer database schema. So that would allow to create the database schema and change the database schema, then deploy the new version, and even if in the transition old instances of the application are still there, you'll be fine, because both can read from the new schema. But let's assume you drop one of the columns. So you take away the description because you found out it's just unnecessary, distracting, whatever. So in this case, your blue version, so your older version, has a database column, and your newer version, the green application version, it does not have the column. So in this case, you cannot directly delete the database column, because in the transition, the two application instances, they would overlap, they would both exist, and requests routed to the old version but on the new schema would fail. So in this case, you'd basically have to deploy a new version, but with still using the old database schema where the column is still present. Wait for the deployment to fully complete so that no blue versions of your application are there requiring the column. Then you migrate the database, and then you have the benefit of whatever dropping that column brings to you as added value.